So first off, I'd like to thank everyone for attending today. Today we're going to talk about some multivariate data analysis in sensory science. So not so much about spectroscopy like we usually do. Um, so let's go forward. So what is it that we can do in sensory analysis? So sensory analysis allows us to describe product characteristics. You can do this by using a sensory panel of experts or by using chemical and industry process measurements and the relationships between those two things. We can also understand our consumer behavior and the likings of our customers. We can do customer studies, see how they relate to our normal sensory panel of experts and vice versa. We can look at an investigation of competitive products. We can also relate product characteristics to the needs of the customers by using some regression analysis. You can predict what a market, how it might respond to a new product, or use your consumer studies to figure out where you might have an opening to add a new product and what type of product they might enjoy. So here's an example case. There was a sensory panel of experts that rated wheat used in products that we were planning on releasing in the Asian market. And the experts show that the U.S. panel experts are actually not in agreement with Asian customers. As you can see, the experts rated these particular wheats relatively high, and especially in Thailand, you see there's a big discrepancy between the consumers and the experts. So we think, well, why isn't this working in East Asia? So it seems that the problem was that in East Asia, most of the wheat goes to production of noodles, and what they like is the slippery texture, and the color that Asians prefer is very different from what the U.S. market wants. So this gives us a way to look at those kinds of things and see what the market is really wanting. And it gets down to just because we like something doesn't mean someone else will. So first thing, we're going to look at some principal component analysis. So if we do principal component analysis on some different types of, these are raspberry jams. We've got 4 different cultivars, so C1 through 4, and different harvest times. So we've got an early harvest, a mid-harvest, and a late harvest. And we can see there is a stretching across the PC1 for your different harvest times. And so what we can do is look at our loadings compared to our scores and see that if we are far to the right on our PC1, then we have a high color and bright redness. And if you're far to the left on PC1, you're seeing thicker jams. So what we see is that our early harvest of our raspberries gives us thicker jams that don't have as much color or the redness that we would expect in those jams. PC2 we can interpret by having a very high raspberry smell or raspberry flavor, and if it's low on PC2, then it's off flavor. And what we can see from that is that particularly our cultivar 1 has a very off flavor. It's not a very good raspberry flavor smell. But C3 and C4 are good as long as we go into the late harvests. We can look at how much of the variation is explained in our loading. So our first loading explains 58% of our data. The second loading explains 28% of our data, the different PCs. So with 2 PCs in this case, we explain more than 80% of our information. Again, this is what I was just showing, is our late harvest gives jam with a high redness and color intensity, and our early harvest gives a thick jam. Cultivar C1 has a higher degree of off flavor, and then C3 and C4 have a distinct raspberry flavor as long as it's harvested later. So let's do another example. and get my unscrambler open here. We're going to look at different fruit cocktails. So what I have here is some data on different fruit cocktails. And we have a bunch of sensory data, the color intensity, odor intensity, orange odor, strongness, sweetness, etc. And then we also have the composition, so what it's made out of, how much is it orange, how much is banana, mango, and lemon. And then we have a mean preference as well. So the first thing we're going to do is analyze using our principal component analysis. Now this is a sensory data from a validated sensory panel, so we don't really need to weight our data. We're going to do a full cross-validation, and this is what we see. So I'm just going to put my labels on. We can show labels here. And now we can look at our explain variance first to see how many components we need to fully explain our data. And I would say that we need about 4. So we wouldn't take any more than 4. So now we're going to look at our loadings. And the first principal component explains 55% of our variance, and the second principal component explains 30% of our data. And so we take a look at how we want to interpret these loadings. And we can see that on principal component 1 shows a high acidity, and then also the odor of banana is a strong indication. If we look at PC2, it looks like we have a color intensity and then an odor orange apart from each other. If we see here, there is a grouping in our data. We see that there are 2 groups of data, it seems like, split along the principal component 2. So this probably is due to color intensity differences. Now another thing we can do, let's look at our other principal components. So we'll put 3 and 4 on here now. And we can see that principal component 3 looks like it's mostly due to the orange odor and the color intensity, and a little bit negative in your acidity and mango. And then principal component 4 looks like it has a decent loading on the banana and then sweetness. So principal component 4 probably explains sweetness the most. So now one thing we can do is we can do our task and do a principal components regression from our sensory data and try to predict our mean preference. Now we show here that it takes about 4 principal components to well explain our mean preference. And we have a fairly decent R-squared, I would say, for understanding people's preferences of fruit cocktail. About 80% prediction rate is fairly good. And we can see we have a fairly linear regression here. And it's mostly their preference seems to be due to the odor of the banana, the sweetness, and the acidity. So people tend to like things that are banana flavored, it seems. Make our list here. And we can do a sample grouping. Let's do a sample grouping based on how much banana is in a particular product. We can create our row sets, bring those over. And you can see that Indeed, we have the banana, the things with higher banana concentration, comes over to the left side, and the things with lower bananas on the right side. Oh yes, using 4 components is a little bit overly fitted. For 16 samples, that's possible. So if we go back here, you might only need about 2 to really explain. It depends on how accurate you want your particular data set. But yes, as you say, there are only 16 samples, so it could be a little bit overfitting. It really comes down to your prediction when you get your new samples in. As you can see here, though, when we do our PLS for our preference, we're only getting about 37% prediction if we go back to 2 principal components. And as you can see, the RMSEs are very varied in here. So another thing we can look at when we're doing our principal components analysis, pardon me here. So the components are sorted according to maximum variance, and in sensory data that might not give an intuitive interpretable components. What we can do is rotate the structure part in order to enhance the interpretation and assign a physical meaning to the components. So here's an example of a principle of rotation. If we look at our scores, they're widely dispersed across our space, and our loadings here, in this case 1, 2, 3, and 4, are in individual quadrants. Now what you can do is rotate these loadings so that the loadings line up along the PCs directly. And that way, each variable is strongly associated with only one component, and it allows you to interpret the principal components a little bit more. So in this case, instead of having a combination of principal component 1 being due to variables 3 and 4 and 1 and 2, when we do the rotation, the principal components are much more linear with each other. So it's just 1 versus 3 and 2 and 4 in this case. So the most popular method is called VARIMAX, and it selects the directions where the loadings are either close to plus or minus 1 or 0. There are a couple of other methods, but they usually give similar results as the VARIMAX. So an important aspect with rotation is the aim is to enhance your interpretation. The rotation works only on the structured part of the data, and so it depends on the selected number of components. And I'll show you an example of that in a minute. So your total explained variance is not changed, but the variance is more evenly distributed among the components. So here's just an example of what our loadings look like before a rotation. In this case, we've got principal component 1 and 2 and 3 and 4 here. And as you can see, they're kind of just all over the place, and it's really difficult to interpret which particular variables are influence the principal components. Or if we do our loadings, our rotated loadings, we can see very clearly now that principal component 1 is very significant due to acidity. Principal component 2 would be smell. Over here we've got crumbly and juicy and off taste for principal component 4. Now I'll show you that in our cocktail example. Here. So if we go in here and we go to our navigation pane and right-click, and you can do recalculate. We don't have anything marked, but it's just, this is the way to do it, unmarked samples. Now we want to choose the maximum number of components here. I believe we stated 4 was the most that we wanted to use. And then we're going to do our VARIMAX rotation. And now what we see is that you can tell very quickly that principal component 1 is due to our orange odor and our banana odor, and a little bit due to thickness, where principal component 2 is due to our color intensity. If we look at principal component 3, we've got it's due to the odor in lemon, and principal component 4 splits out our acidity and our sweet. Now, if we wanted to go back, we had the question about overfitting. So we can recalculate with our match samples again. And let's bring this down to, say, 2 principal components. Make sure we do our VARIMAX rotation. And as you can see, it's not quite as easily interpretable as it was before, which makes me think that it is it's probably better to use more principal components because they're not completely lining up. You're not getting all of your variation in this case. So the next thing we can do, I touched on it briefly, was principal component regression. And what that allows us to do is you do your principal components analysis, and then using your new principal component space, you fit a Y data to it like a preference. And so you were able to look at your samples and sensory attributes versus your customers. It's a very common problem solved by principal components regression in sensory science. So there's a couple of different ways to do this. You can do internal preference mapping. What you do here is you do a principal components analysis of your consumer data. So your sensory attributes are regressed on the principal components, and the product map is defined by the customers. So your customers are your scores, and your sensory attributes are your loadings. You can then also do external preference mapping. That's where you do your principal components analysis of your sensory data, and then the consumers are regressed onto the principal components. The product map is then defined by the sensory panel. Now, in these cases, the interpretation is pretty much the same. You're just making sure to describe the variation in one or the other differently. So I'll show that in just a minute. So when we're looking at the consumer preference data, the orientation of the matrix makes a difference. If you have a tall, thin matrix, that's where your consumers are your samples and your products are your variables, it will not show if any product has a very different average liking. So consumers located in the middle of the score plot have no strong preferences. If we do our products versus our consumers, the variance for each customer is modeled, and the average preference is not important. This shows systematic variations among consumers, and the actual range for each consumer is not that important. So let's open up an example for that on some cheese data. So what I have here is some data that are 6 different types of cheese and some sensory information, the shiniest, the hue, different odors and flavors, and then people's individual preferences for the different types of cheeses. So if we do a task principal components regression here, first what we're going to do is use our preference data, our consumer data, to explain the sensory data. And what we can see here, if we look at our correlations loading, so we can understand what's going on here. You can see there's a general grouping of your consumers over here. So these people, most of your people seem to prefer cheeses that are salty, that are very juicy, have a mature and acidic flavor, and things that are not very firm or coarse and aren't very astringent. So you have a couple people that like those types of data, but for the most part, people like these types of data, or these types of cheeses. We also see there's kind of a second grouping along here on the principal components too, things that have a nut flavor or a, let's see what this one is. We can zoom in, maybe. Yeah, nut flavor and nut odors. So there's a group of people that like those type of flavors. So this would tell you if you were making a type of cheese and perhaps you had some cheeses that were very mature and had the very acidic and salty, and you wanted to see what the next best-selling cheese you might have, then you would maybe look for something that would have a nuttier flavor to supplement your original line. So we can go back and do the analysis the other way. PCR, we want to use our sensory for our preference. And let me go back to the original regression for a moment. And what you can see here is that it takes 40% of our information, of our consumer information, to predict 53% of our sensory data. And here we've got principal component 2, 21% of the variation in the consumers explains another 20% of our cheese information. If we go back where we did it the other way, what you see now is that 70% of our sensory data is now being explained because we've done the principal components analysis on the sensory data itself. So it's maximizing the variation in that sensory data. And as we can see, we have a similar interpretation that a majority of the people prefer mature, acidic, and I believe salty cheeses, and ones that are not so firm and not very coarse. And then our second biggest grouping is going to be that mature over the acidity and then a darker hue. How do you determine whether the panel ratings are valid? So what you want to do there is you look at how your sensory responses and your consumer responses overlay with each other. So you would need to have probably something like this where you had a preference for your sensory panel as well and see how they overlap with your consumer preferences as well. I don't have any particular data to show that at this point. So here's our example again of the cheese data that shows your internal preference mapping. So like I mentioned, most of the consumers are located on the right part of the plot, and they like cheeses with the mature flavor and odor that are not bitter or astringent. These customers do not agree with the majority. They seem to have a preference for bitter or astringent cheeses. And again, this is now our external mapping using principal component regression. You have the same conclusions as before, but our sensory attributes are now better explained than the customers. So which one do you choose when you're doing your analysis? So when you're doing your internal preference mapping, the consumers are the ones that define the product map. So it's going to explain how much your consumers like things. Can your consumers describe the variations related to the sensory attributes? In the external preference mapping, your sensory analysis describes the products. So it sees how each consumer relates to the different sensory dimensions. So there's different strategies. You can define your segments based on your demographics. You can do a PCA on the demographic data. Does their preference vary between these segments? Do you define segments based on preference? You can do your PCI and your preference data, and if that relates back to your demographics. So you define your segments by visual inspection of your scores and loadings plots, and you can do cluster analysis. So I'll show you that here. It does seem that we have two groups of data of people. So if we do a cluster analysis on our preferences, I'm going to do k-means, squared Euclidean, okay. Now what this is going to do is it shows us our preferences for cheeses. So I did that wrong. What we need to do is take this preference data, duplicate the matrix, just our preference, and now what we need to do is transform. We're going to transpose so that our customers are samples now. And it's each customer, how well they prefer the different types of cheeses. Now we can run a principal components analysis on this. And a cluster analysis. K-means 2. Now this gives us an output and it shows us each customer, which class they fall into, 1 or 2. But how we can use this more efficiently is to go back into your principal components analysis, which was of our preferences here, right? So if we right-click, sample grouping, now what we can do here is there's this select result matrix. This allows you to use results from a different analysis to make your groupings and markings. So we did a cluster analysis here. If we expand this out, under rows it shows us 2 clusters. We just double click on cluster 0 and it adds available row sets with those 2 different types of people. So we can apply this and we can see there is a preference difference between we have 2 groups of data that have a preference difference. So mostly it seems like the people in blue prefer cheese number 2, and those in red do not prefer cheese number 2 and probably prefer cheese number 5 and 1 instead. Now we can go back and look at how these show up on our principal components regression. So principal component, cheese number 2 is one that has a very sunny flavor. It's firm and it's coarse. So those are our unusual people that tend to like those firmer, more bitter and astringent flavored cheeses. And cheese 5 here is those ones that are more acidic, that mature flavor. So that's how you can use those groupings and loadings. So here's your workflow. When you start an analysis, you need to define your goal. Are you using your consumers to predict your sensory data, or are you using your sensory data to predict where you want to go in your consumers, into your consumer space? Define your products and your attributes that you want to look at, and then you design your experiment. Then you monitor your panel performance. That's going to be your sensory panel. Do a quality check and prepare your data for analysis. If you don't have a well validated sensory panel, you may want to weight your scores or weight your variables so that to make sure that they're on the same scale. Then you're going to do some exploratory analysis. That's that principal components analysis to get an idea of what the differences in your cheeses and your consumer preferences are. Then you do your preference mapping and regression analysis. And then you might do an LPLS regression, which I will show you. Close these out. Now, what we have in this data set is children were asked how much they liked specific types of apples. Okay, so we have our data split into different types of matrices. So here we have 6 different types of apples: Granny, Gala, L-Star, Gloucester, and then we have different sensory and chemical information about them, which ones are acidic, which ones have sugars in them, the round, how red they are, sour and sweet. And then we have each child tries each type of apple and says how much they like those apples. And in this block we have some information about our children. So whether they're male or female, what age they are, if they were given a list of fruits, which would they choose first and which would they choose last. And so this LPLS allows us to do a 3-way partial least squares analysis to look at how all these different factors affect the liking of the particular apples. So if we go to Analyze LPLS Regression, so I'm going to do X, Y, and Z here. Now, in this case, I do want to make sure to weight all of my data because children are not very validated sensory panel people. And then we also have some differences because we have sensory and chemical data. We need to make sure that they're not biasing our model by having an especially high value, for example, or a wide variance. So this is going to show us how many factors we need to explain our different pieces of the information. To explain our X block of data, we can get in 3 factors. It's pretty well explained, but for the Z and Y block, we need to go all the way up to 5. So if we look at our correlation loadings, this is going to be our most important. We're going to look at all of these together. So what we see here is that we look at how all these relate to each other. So on factor 1 here, we have red, sweet apples. And we can look at our factor 1 for our Z. So this is the information about the children. So the children who are older tend to choose red apples first, tend to eat apples often, like these sweet red apples. And those are your Gala apples, your Jonah, and your Gloucester, which makes sense. And if you come over here in our in our Y block, you can see the Granny Smith apples are round and not red, so they're green. So this gives us a way to understand what the differences of our products are, where they fit in with our different sensory information, and then how our customers' demographics relate to those things. So again, the steps in your multivariate analysis, you want to evaluate your panel data, check your assessor performance. You import your data into the unscrambler and work on any averages, category variables you need, variable sets and sample sets. You inspect and plot your raw data. You might do some statistics to look at your variations in your data. I will show you that here again. So if we look at our sensory and chemical information, we can do our descriptive statistics on all. And as we can see here, we have very different ranges of our different variables. And so that tells us that we are going to want to scale our data, because otherwise this sugars will have an undue bias on your model than these acids and sugars in this case versus your round and red. So you want to make sure that they're on the same scale with each other when you're doing your analyses. So then you want to do your principal components analysis on your panel or in your consumer data, see how they line up with each other. And then you can do your preference mapping and your cluster analysis, and then you're going to validate and interpret your results. So that's all I have for you today. If there are any questions, I will happily take them now. Give you a few minutes to type away. All right, it looks like everything seems to have been covered for now. If you have any questions, please feel free to email me at hbrook with an E at camo.com, and I'll be happy to follow this up, and I'll be happy to help you with any further questions you might have. I am recording this, so this will be up for you to peruse later as well. Hope you guys have a great day, and thanks for attending.